Find the y parameters of the below given two-port network. This is the two-port network given in the question, and here we have 1, 2 and 3 resistors, and we have one current dependent current source, and we are required to find the y parameters of this two-port network. And we will first obtain the z parameters of this two-port network, and once we have the z parameters, we will convert them to have the y parameters. And we know in step number 1, to calculate the z parameters, we assign the currents in all the branches of the two-port network. So let us perform this step number 1. In this branch, current is I1. In this branch, current is 2 times I1. And when you focus at this particular node, you will find 2 times I1 is entering the node and I2 is also entering the node. Therefore, the leaving current according to KCL will be 2I1 plus I2. Therefore, the current in this branch is 2I1 plus I2. Now focus on this node. I1 is the current entering the node. 2I1 plus I2 is the current entering the node, but 2I1 is the current leaving the node, and therefore the leaving current in this branch will be I1 plus 2I1 plus I2 because it is also entering the node. 2I1 plus I2, then we have minus 2I1 because it is leaving the node. Minus 2I1 and 2I1 will cancel out, and we have I1 plus I2 as the current in this branch. So we are done with our step number 1, and now we will move on to step number 2, in which we will obtain the input KVL equation and the output KVL equation. So let's find out the input KVL equation. We will have plus V1, then we have minus 8 multiplied to I1, minus 8 multiplied to I1. After this, we have minus 2 multiplied to I1 plus I2, minus 2 multiplied to I1 plus I2 equal to 0. From here, we will have voltage V1 equal to 10 times I1 plus 2 times current I2. Let's say this is equation number 1. Now we will obtain the output KVL equation. We will have plus V2, then we have minus 4 multiplied to 2I1 plus I2, minus 4 multiplied to 2I1 plus I2. After this, we have minus 2 multiplied to I1 plus I2, minus 2 multiplied to I1 plus I2, then equal to 0. And simplifying this, we will have our equation number 2, that is voltage V2 equal to 10 times current I1 plus 6 times current I2. This is equation number 2. So in this way, we have obtained our Z parameters. 10 is Z11, 2 is Z12, 10 is Z21, and 6 is Z22. And now we will obtain the Y parameters, and we know Y11 is equal to Z22 divided by the determinant of impedance matrix. Z22 is equal to 6, so we have 6 divided by the determinant will be 10 multiplied to 6 minus 10 multiplied to 2. 10 multiplied to 6 is 60 and 10 multiplied to 2 is 20. So finally we are getting 6 divided by 40, which is 3 divided by 20, and the unit will be mho. Now we will find out the next Y parameter, which is Y12. Y12 is equal to minus Z12 divided by the determinant. Z12 in our case is 2. So we have minus 2 divided by 40. And this is equal to minus 1 divided by 20. And the unit will be mho or Siemens. Now let's find out the next y parameter, which is y21. And it is equal to minus Z21 divided by the determinant. Z21 in our case is 10. So we have minus 10 divided by 40. And from here we will have minus 1 divided by 4. And the unit will be mho or Siemens, or you can draw inverted omega. Now we will find out the final y parameter, which is y22. And y22 is equal to Z11 divided by the determinant. Z11 in our case is 10. Therefore we have 10 divided by 40. And finally we have 1 divided by 4. The unit will be mho or Siemens or inverted omega, or you can write ohm inverse. So in this way we have obtained all the 4 y parameters of this 2-port network. And now I will give you the homework problem of this lecture. So this is the homework problem. Read it, and once you have your answer, post it in comment section.